This is a video for AQA Further Pure Mathematics. This is Vectors section 1.2, where we're looking at the scalar product of two vectors. We've already seen in a previous video that we can add and subtract vectors, but we haven't actually considered multiplication as yet. There's more than one way of defining multiplication of vectors. We're looking at what's called the scalar product, which is so called because it produces a pure number. So the scalar product we find by finding the sum of the products of the corresponding elements in a vector. So the x components multiplied together, the y components multiplied together, and then the sum of those. It's useful because we can find the angle between two vectors from the definition of A dot B, the dot product. The dot is used as the symbol and sometimes interchangeably as a name. So the scalar product or dot product, we can refer to both interchangeably. Well, we said that we find the scalar product by looking at the sum of the products of the corresponding elements. So just to write that out algebraically then, if we've got two vectors A and B with their corresponding x and y components, then the dot product is A1 B1 plus A2 B2. So a simple example of that would be, for example, if A was the vector 2, 3 and B was the vector 3, negative 4, then A dot B would be equal to 2 multiplied by 3 and then plus 3 multiplied by negative 4. And that gives us a total of negative 6. Now clearly, because multiplication is commutative, then the dot product is going to be commutative, so that we can say that A dot B must be equal to B dot A. If we move into 3 dimensions, there's simply the z component to consider, so that the definition remains the same. We're looking at the sum of the products of the corresponding elements. And we can look at a couple of examples of that. Example 1 here, we've got P and Q. You can see there we've got it written in its vector form. So P dot Q is simply 2, negative 4, 3 multiplied by negative 2, 1, 3, or dot product with. So that gives us negative 4 plus negative 4 plus 9. So we can see there that P dot Q will be equal to 1. In the second example, they're written out in the component form using the unit vectors I, j and k. Notice that in the second vector B there is no j component. So here we get A dot B. The components are 1 multiplied by 3 in the I direction. In the j direction it's negative 2 multiplied by 0. And then for k we have 5 multiplied by negative 1. So in total there we have 3 and then negative 5, so negative 2. There's an alternative definition of dot product, A dot B, which is to say that it's the modulus of A multiplied by the modulus of B and cosine of the angle between A and B. So on this diagram here we would have the modulus of A, the length of A, the length of B, and then multiplied by the cosine of this angle here. Now this can be proved using cosine rule. You might want to research it or look in your textbook to find a proof. It's quite important because then we can rearrange this and we can see that therefore cosine theta must be A dot B, the dot product, divided by mod A mod B. And it's this formula that we will consider in the next video to find the angle between vectors. That completes this introduction to the dot product. And say in the next one we'll be looking at the angle between two vectors using that formula that we've just derived.